Good afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In the video lecture series, I'm discussing about the wireless technologies for IoT. In that, I have discussed about the overview, architecture, and the conceptual framework. Now, we'll discuss about the sources of IoT. The various sources of IoT are sensors and control unit, radio frequency identification module, wireless sensor networks, communication modules, and the software development tools. Sensors, the various sensors which is uh, used to sense the devices are analog sensors, digital sensors, and presence sensor. Where analog sensors are here, we are using thermistor, photoconductor, pressure gauge, and the hall sensor. Then digital sensor is nothing but touch sensor, proximity sensor, metal sensor, and the traffic sensors. Then the presence sensor which we are using is rotate encoder for measuring the angles and the linear encode for the measuring position. Then control unit. The most commonly used control unit in IoT are microcontroller unit and are a custom chip or core in a VLSI. Then the popular microcontrollers which we are using are Atmega microcontroller. It is of various types 328, 32U4, ARM Cortex and ARM LPC. This is the structure of a microcontroller unit, the control unit of the microcontroller. It consists of processor, internal RAM, internal flash and firmware, timers, programmable I/O ports, general purpose I/O, serial I/O. Then pulse width modulator, analog to digital converter, and the communication interfaces. Then Arduino board. Example Arduino N. Here using microcontroller Atmega 32U4. It includes Wi-Fi, Ethernet, USB port, micro SD card, and other reset buttons. Then it also runs the Linux. Then Intel Galileo board, a line of Arduino certified development boards. Then Intel X86, Intel SOX into 1000, which is nothing but wax based system on chip. Then power over Ethernet and the 6 analog inputs. Here then we're using BeagleBoard. BeagleBoard is nothing but it is also a mm, it is also a hardware component which is used in the microcontroller in the Arduino board. It has very low power requirement and it is like a card-like computer. It can run Android and Linux. Then in the open source hardware designs and the software for the IoT devices, this BeagleBoard is used. Then Raspberry Pi, it is nothing but a Wi-Fi connected device which includes code open source Raspberry. Then the next one is radio frequency identification module. In the name itself we have identification system which is mainly used for tagging and labeling. It consists of a tiny chips with passive active and battery powered when readed by the nearby wireless communication which ranges from 10 centimeter to 200 meter. Then the standard frequency ranges are 120 to 150 kilohertz, 13.56 megahertz and the 433 megahertz, and it has higher in ultra high frequency range and the microwave regions, and it is mainly used in various RFID applications for tracking and inventory control and in the supply chain systems. Then in order to store the center entries, the application here uses is factory design, 3PL management, pan protection and anti-counterfeiting. And for business process, this is used for payment, leasing, insurance and the quality. Then in wireless sensor networks, it is mainly defined as a network in which each sensor node connect wirelessly. In communication modules and software development tools, we have device message queue, device message cache, which stores the received messages. Then the protocol handlers such as constraint application protocol, hypertext transfer protocol, message queuing, telemetry transfer protocol, and message constraint application protocol, message queuing. This is the communication module. Then the representational state transfer and REST architectural style, which is used for hypertext transport protocol access, and it is used mainly for building the web services. Then the middleware is an open source middleware which is mainly used for communication with sensor clouds and cloud based sensing as a service. Here the protocol which we are using is a open building information exchange. Then Raspbian Pi is operating system which is based on the defined distribution of the Linux. This is the IoT architecture, software architecture. Thank you.